Right, so here is the basic equipment that is going to be used in the Ohm's Law lab. We have a power supply here. It has DC and AC. One way that you can tell is one, it's labeled on there as DC and AC. However, the other one is that this has two different colors and those are the same color. Traditionally, red is the high potential side and black is the low potential side. And over here, because the potential flips back and forth, which is the high side and low side, they're the same color. Currently it is off, and let's just hit those just to make sure that, well, I don't need to hit that one, but I do it anyway. And there's one on the back also. Just making sure that it is working before we begin. In theory, this goes up to 12 volts, but in reality it goes up to, it says 12 volts right there. In reality, it goes up to around 14, but at 100% it should be about 12 volts, give or take 2 volts. And this is going to be our resistor here. This will be resistor 1. Currently, I've set it for 1,900 and no tens. So it should be about 1,900 ohms. Now let's actually check to see what the resistance is. So for that, I'm going to use the multimeter and set it on resistance. If you'll notice over here, we have various units and symbols here. So this is what I use for measuring voltage. That's the omega, the symbol for ohm. That's what I use for measuring resistance. And that's this one where I'm measuring capacitance, frequency, and then I measure current here. It has 3 different settings for current here. This measures microamps, milliamps, and up to 10 amperes. 10 amperes is the only time, if we're measuring that high, is the only time we'll be using this port. Otherwise, we will be using these 2 ports for pretty much anything that we do in this lab, in this course actually. And so this is the low side here. Common is the low side, and this is going to be the high side. Now, one of the reasons why we're not going to go up this high right here is that if you look on the resistor, there's a 1/4 ampere max. And I have exceeded that before, and what happens is that you start smelling burning plastic as plastic inside starts to burn. It's indeed a lovely smell. And on one of the resistors we're using, we have fried part of it. It's still usable just so long as we follow the message that is written on it. But we'll get to that later. To measure resistance, we put this on ohms. We have, it doesn't really matter which side is hooked to which at this point, since there is no high or low side as far as the resistor is concerned. It's not hooked to a power supply. But I do have one of the probes here connected to this side, the other one connected to that side. And we have a reading here. Now, ideally, it was set to 1900, but we're a little bit off, and that's just to be expected. So notice that is kilo ohms right there, 1.902, just at the very moment. Whether that's what you settle on or not is up to you. It seems to be flipping back and forth between 2 different resistances. And so pick the one that feels like it is closer to accurate. And so that'll be the resistance for resistance 1. We're not going to measure the resistance of this resistor. Again, for the rest of the lab, we're just going to trust that it is accurate. There, that seems like a pretty good shot. And that's probably enough for you to draw some conclusion. So we now have a circuit here. We have current that'll be flowing out of the high side. When I say high side, I'm referring to the high potential and the low potential. So current flows from high to low potential. This is not potential energy, but electric potential. So current's going to be flowing out of here along this red wire here into this lead of the resistor. It's then going to flow through the resistor into this one, and then from that through this wire, which leads straight back into the low side here. And so current will be flowing around that way. So since this is the high potential side, this is the high potential side on the resistor and the low potential side. So when I measure voltage, I want to connect the high potential side of the multimeter, the volt side of the multimeter, I want to connect the high side here with the high side of the current flow, and the low side if I want a positive value. And we'll just kick that off and see what happens. I have the high potential side of the meter hooked into the high potential side of the power supply, and then the low potential connected to low potential. And so right now it's not measuring any voltage because the thing is turned off, but let's turn it on and find out if I've got power flowing into it. All right, so that is the potential now that I've turned it on. Obviously it's more than 12 volts there. And it looks like it's settling. So we're going to be using that value for the experimental potential off the power supply. Notice what happens if I switch the leads here. I'm just going to flip around. I haven't turned it off. There's not real danger of blowing a fuse. That will come later. I have the high side of the meter hooked to the low side of the power supply, and notice that we now have a negative voltage. So in terms of accuracy for this lab, we're going to ignore any minus sign in case I have something that gets hooked up backwards. I'm going to try not to do that, but minus sign pops into one of these values, we'll just ignore it. Now I'll put the circuit back the way it is. Now I want to figure out what is the potential across the resistor when it is turned on. So this is the high side, the higher potential across the resistor. And then I will take the low side here and plug it into there. And that is the potential drop actually across the resistor, which makes sense. That is about the same thing we had before when we were looking at just the power supply, because whatever we gain across the power supply, we should lose going across the resistor, because Kirchhoff's rules talk about that. The sum of all the voltage gains and losses should add up to zero when you get back to where you started. Now, I have been through this lab before, and I know that the current should be in the milliampere range, and so we will set up for that. Just remember, when you're measuring voltage, you measure that in parallel. So that's why I had the circuit set up the way it was, and then I connected the leads. When I'm measuring current, I need to make sure that the current flowing through the meter is the current flowing through the stream. So I will set that up and be back. I'm about to set this up to measure current. And before I do that, a couple of things to help minimize the chances of blowing a fuse in the meter here, because that's just a nuisance when that happens. One, I made sure the power supply is off. And two, I have the circuit set up without the meter in it. That's just as a starting point. Now, if I want to measure the current flowing out of the power supply, I need to put it somewhere between here and here. And so what I'm going to do is I'm just going to unplug that and plug this into here, and then connect these. I'm going to double check here to make sure that it makes sense. So current flowing out of here is going to flow across here through the meter. Then the current goes through the meter, around the wires, into this resistor, through the resistor to here, and then back to the power supply. So the current flowing out of the power supply has to go through this. So that's why this will measure the current out of the power supply. And so now I put this over on milliamperes because I've already calculated sort of what it should be. And now we turn it on. And that seems rather stable there. Nope. Now it's deciding to between two. All right, so you decide. All right, so that is the current flowing out of the power supply into the resistor 1. Again, before I put the meter into the stream to measure the current, I make sure that I have my circuit set up properly, which it is. It is turned off. And now I want to measure the current flowing out of the resistor 1 and into the power supply. I think the directions ask for the current flowing out of the resistor. So, I'm connecting it into the stream. It doesn't matter if I connect it here or there, but I'm going to connect it here. So I'll pause it while I set that up. Now let's make sure that before I turn it on, everything is set up right. So current's going to flow out of here through the red wire to the resistor. It's going to go through the resistor and then out this wire into my meter. And it's going to flow through the meter and then out here along the wire and back into the power supply. So whatever's flowing out of resistor 1 here will have to flow through the meter. So now we turn it on and rotate that. So we do have the current. That current should be roughly the same as what it was before. I don't remember what it was before because, yeah, I just don't remember those things. That's why I record it. That's right, it was between 724 and 725. There's a slight difference because, it's physics. Ideally, they should be the same, but in reality, they are just close. Let's see if I can get something that's not shaking there. Make sure all the connections are good. All right, so now it's sort of hovering between two. And you make the call. Now we're going to set it for procedure B. This is resistor 2. It is set up somewhere around 3050. This is a situation I'd mentioned earlier about if you fry the insides. So it's okay as long as this is not on 0 or 1. That's why I don't have it on 0 or 1. Okay as long as the 10 is not on 0 or 1. Yeah, the broken, the hundreds, and the thousands are scratched out. And if you looked inside, you would see that it's melted a little bit. Let's measure the resistance of it. So now we are measuring the resistance. So I have one lead leading to here, the other lead going to the other side of it. Right now it's measuring 0 because I have this thing set to measure current, and there's no current running through it, fortunately, because that would be a bad way of measuring current. So what I care about is resistance, so I put this over on that. And it should be somewhere around 3050. And lo and behold, it's somewhere around 3050. Let's see if I can stabilize this so you can make a call about what the actual number is. And I'll just check to make sure my connections are good. All right, that's probably been there long enough for you to decide. All right, I'm going to pause it and put it into series with the other resistor. So now measuring resistance in series, we have the current coming from the meter going through this resistor, resistor 1, and into resistor 2, and then back into the meter. So that is the equivalent in series. And that's roughly the sum of the two of them separately. And it seems stable at the moment. Here is the basic setup for procedure B. Two resistors in series. So current is going to be flowing out of here through this wire into this resistor. This is resistor 1. It's going to then flow through the resistor out this wire right here into resistor 2. Resistor 2 is the one that's somewhere around 3050 ohms. Then it's going to flow through the resistor, through that wire, and then back into here. So that is the setup. I've had this on the whole time, so let's turn that off just as a matter of, we really should do that between takes. There are other labs where if you don't do that, things heat up and start changing results. But in this case, it's relatively low current. Let's now set it up for measuring the voltage. Now the voltage across the power supply really should not have changed much. I have this, the high side of my meter going into the high side of the power supply, the low side of the meter going into the low side of the power supply. Everything else is set up as is. Now I turn it on and we let the magic happen. And so that is the voltage of the power supply, which I believe is about the same as it was before, which is good because it should be. So now we're going to do the voltage across the others. So I just unplug my voltmeter from the power supply, and now I hook it into here. And that is the potential drop across the resistor 1. That is the potential drop across resistor 1. It is not the same as it was before, because remember, the voltage gain here should equal the voltage drop here plus the voltage drop there, because this is series. Current has only one path to go. It's going to gain potential, lose, and then it should be back to 0. So that is it across resistor 1. And now let's try resistor 2. So I just unplug from here, unplug from there, connect. The nice thing about the banana plugs is that this is a whole lot easier than if we were using the probes themselves. All right, and that is the potential drop across resistor 2. It has the higher resistance. It's the same current flowing through both ideally. So the one with the higher resistance should have the higher potential difference. And it does. Now this voltage here plus the voltage we got from resistor 1 should add up to what we had for the power supply. Now since this is physics, good luck that it actually matches perfectly, but we should get pretty darn close. And let's make sure connections are stable or solid. All right. And we'll stay on this long enough for you to make a judgment call. It's obviously floating back and forth between 2 or 3. All right, hopefully that is enough. So now I'm going to set it up to measure current. I remembered to do it this time. I've turned the power supply off. I have the circuit set up exactly the way it was before. So we have the current flowing into resistor 1, into resistor 2, and then back to the power supply. So to measure the current out of the power supply, I'm going to pull that out. And then I take this side And now before I turn the power supply on, I am going to double check. So current flows out of the power supply into the meter, through the meter, into resistor 1, and then through resistor 2, and then back to the power supply. So I think I am ready. Oh, we need to set this on milliamperes. Now I am ready. And notice this is 0 right now because the power supply is off. And now I turn this on. And that is the current flowing out of the power supply. And it seems to like that value. So now let's set up for measuring the current flowing out of resistor 1. So again, set up exactly the way it is before. The meter is not part of it, but we do have current flow through in this, basically this loop right here. And so what I'm going to do is I want to measure the current flowing out of resistor 1. And so this is where I'm going to interrupt the stream. Oh, what I did forget to do is turn that off. And so now let's set up. Just to give you some idea of how paranoid I should be here, I did blow a fuse earlier, a couple days ago, and didn't realize it, so I've got bad results. So this is actually not the first time I've run this lab at home. And also, I'm not sure I snagged enough meters from school because we have quarantine going on. And I do need to be concerned of if I blow too many fuses, that means I have to go back out to school, which means potentially socializing with people, and that is anathema. All right, so let me pause this while I connect because apparently I need a third hand. We have the circuit set up as it was before, current flowing out of the power supply through this resistor, through that resistor, and then back to the power supply. To measure the current coming out of resistor 1, I'm going to pull that and put this into the stream. And let's see how well I can do this while filming. 1 down. And now connecting this. The power supply is turned off. And I did it. All right, so current flows out of the power supply through resistor 1, through the meter, through resistor 2, and then back to the power supply. As we flip this on. And there's the current flowing out of resistor 1 into resistor 2. I've secured the connections, and there we are. Now let's set up for the next one. Current flows out of here through the resistor into the second resistor and back, and the power is off. So make sure everything is sort of set up. So now we want to measure the current flowing out of resistor 2, which means I am going to set up my meter to intervene right here. So let's go ahead and do that. Just double checking before we turn the power supply on. We have current flowing out of the power supply through resistor 1, across this wire, through resistor 2, through the meter, and then from the meter back into the power supply. So that is set up exactly the way it should be. This thing is set to measure milliamperes. And so let's go ahead and turn it on. And that is the current flowing out of resistor 2 into the power supply. I just want to point out a little side note right here. If you'll notice right there, it is measuring in DC. If I hit select, it would then try to measure AC and making assumptions that are not valid, such as oscillating voltage. But the AC lab is later. All right, that seems rather stable. Let's stop this and set it up for procedure C. This is resistor 1 and resistor 2 in parallel. So I want to measure the equivalent resistance of the two of them. So I need to put one of the leads of the meter on this side, one of the leads of the meter on that side. So let's go ahead and do that. So I'm going to put that here. Now in theory, it doesn't really matter if I connect here or here. So I'm just going to connect it to that side right there. And that is the equivalent resistance of resistor 1 and resistor 2 in parallel. Notice that total resistance is less than either individual resistance, as I would expect. So it looks like it's oscillating back and forth between two resistances. Let's take a look at the setup. Current flows out of here, it gets to this point. There is a junction. The wire, in other words, the current has a choice of going two different ways. Part of the current is going to go through resistor 1. Part of the current is going to then split off over here and then go through resistor 2. After they go through the resistors, they are going to meet up again over here. This is where the current going across this resistor comes in, and that wire right there, that is where the current coming from resistor 2 comes in, and then they join up and come back into the power supply. So first thing we're going to do is measure voltage. So let's turn that on and measure the voltage across each. Because this is a parallel structure here, I would expect the voltages to be roughly the same. There is the voltage across the power supply. So now let's set it up for doing the next one. So let's pop that out of there and pop that one out of there. I accidentally hit the data hold button. So now I plug the voltmeter in there, and I plug the voltmeter in there, and there is the voltage across resistor 1. See if I can do this without glare. Voltage across resistor 1. And now we will take that, plug into here, take that one, plug into here, voltage across resistor 2. And now we'll set up for doing current. Power supply is turned off. I have the setup exactly the way it was before, and so now to measure current. So if I want current out of the power supply, I need to disconnect before the junction. So I'm going to disconnect there, bring my meter into it. So that current is going to flow out of here through the meter, and then from here into this wire. Let's get this thing set on milliamperes. And so current flowing out of there through the meter into here, into our basic structure, and then back. So I'm feeling good, so let's turn it on. So that is the current flowing out of the power supply. And I think you can make a call at this point about what the actual value is. So let's set up for measuring the current going out of resistor 1. That off. So this is the setup again without the meter in play. And if I want to measure the current flowing out of resistor 1, I need to do it coming out of resistor 1 here, but before the junction. And so I'm going to disconnect here. And that's where the meter is going to go. So let's see if it makes sense. Current flows out of here, gets to this point, and splits, going through resistor 1 and resistor 2. Then it goes through resistor 1, it gets to here, it then goes through the meter, and then connects up with the current flowing out of resistor 2 and the stuff that went through the meter, and then back to there. So it's looking good. So current flowing out of resistor 1. All right, so now let's do resistor 2. So I'm turning that off. So I have the setup as it was before, power off and everything else. So if I want the current flowing out of resistor 2, I need to, well, this is the current flowing into resistor 2 and out of resistor 2. So this is where I connect. Current flows out, splits, gets to here. Current flowing out of this will go through the meter and then connect up again into here. Make sure we've got a good connection there. I'm feeling good. So let's turn this on. And that is the current flowing out of resistor 2. Now, Kirchhoff's junction rule says the current flowing into a junction equals the current flowing out of a junction. So if we go back and look at the current that was flowing out of the power supply, that should equal the current flowing through resistor 1 plus the current flowing through resistor 2. Or as we measured, the current flowing out of resistor 1 plus the current flowing out of resistor 2. And then back to here, this is again current flowing out of resistor 2. And now we will bring in a third resistor. This is resistor 3 right here. I have it set up somewhere around 4,000 ohms. Let's find out what it actually is. So if we're going to measure resistance, let's put it on the omega there. It should be on overload because there should be incredibly huge resistance going through the air. We'll now connect it. And we have the resistance of resistor 3. See if we can get it without glare. I'm not sure which one is better, but there they are. Now let's put it into the circuit. It is to be in series with the parallel 1 and 2. This is measuring the equivalent resistance of 1 and 2 in parallel, and that structure in series with that, and just to make sure. So current coming from the meter there comes to this point, and it splits. Part of it goes into resistor 2. Part of it goes through resistor 1. It goes at what comes out of 1 and 2 will join up again, and then that will go into resistor 3, and then resistor 3 into there. And so that is the equivalent resistance for part D. And that's pretty stable, at least to the, I guess that'd be the tens place. So we have 1 and 2 right here. What I'm going to do is the wire that was going to the power supply, I'm going to pull that out of the way. Current flowing out of the power supply comes along here. It splits at this point, part of it going through resistor 1, part of it coming over here to resistor 2. It comes out of resistor 2 and out of resistor 1. At this point, those two join up over here, at which point the current rejoins, then comes out and goes into resistor 3, from resistor 3 into the power supply. So that's looking good. Let's turn it on, and now let's just measure voltages. The voltage across, so make sure that is on volts, which it is. Then let's just connect in there. And connect in there. And that is the voltage coming out of the power supply. Again, just going to make sure that all my connections are good before we settle upon this shaky value right there. Let's check those. All right. Roughly what it was before, not exact, but roughly. All right, so hopefully that was enough. So now let's find the voltage coming across resistor 1. So just a matter of taking these leads and putting one in there, and putting one in there. And so the voltage across resistor 1 and now for resistor 2, I'll probably have to move that. So just a matter of taking the leads and put them in here. Measuring voltage is really easy from a practical point of view. The voltage across resistor 2. Okay, make sure I've got solid connections here. All right. And now let's go for resistor 3. I would expect it to be somewhere around 10. Because remember, the voltage, we gained voltage going across here. That was 13 point something. And then we're going to lose it going across these. They're in parallel, so it doesn't matter which path we take. We lost 3 point something. And so this is why I'm predicting this to be somewhere around 10. So we take the 2 meters. Make sure my connections are good. And there is the voltage across resistor 3. We'll be measuring current next, so first thing I'm going to do is I'm going to turn the power supply off. The power supply is off just to make sure current flowing out of the power supply is then going to go into my meter here. And then from my meter, it is going to go into the wire that goes into resistor 1. So everything else stays the same. So again, just make sure my connections are still good. And turn this on. And this is the current flowing out of the power supply. Now it's set up for the current flowing out of resistor 1. Let's turn that off. So we have current flowing here. This setup is just the same way as it was before. Now, in order to measure current flowing out of resistor 1, I need to connect it here. So bring my meter in. So when it flows out, it is going to go through the meter, and then the meter back into the wire in which it was connected. Out of the meter, back into the wire in which it was connected, and that's the one that hooks up to this junction right here. So let's go ahead and turn this on. Actually, let's make sure connections are good. It is set to measure milliamperes. And when I'm checking to make sure the connections are good, all I'm doing is just squeezing to make sure that something didn't come loose. So let's turn it on. Current flowing out of resistor 1. Let's put things back the way they were, turn that off. That is turned off. Everything else is set up exactly the way it was before. My meter is not part of the stream. Now to measure the current coming out of resistor 2, since current flows into resistor 2 this way, I need to connect it in here. So I'm going to disconnect that. And that's where I'm putting the meter. So meter is now part of the stream, so something flowing out of resistor 2 will connect into that and then into that junction that we had. So let's go ahead and turn this on. Now I would expect that current to be less than what we just saw coming out of resistor 1, because resistor 1 had less resistance, and more current flows the path of less resistance. So the sum of the current going through 1 and 2 should add up to what's coming out of the power supply, or it's physics experiment, so close. And then it should also match what's flowing out of resistor 3. All right, I'll hold it there just a little bit longer just to make sure that you have enough to judge. All right, obviously oscillating between two numbers. I'll set up again, so I'm going to take the meter out of the stream. Current flows here into this junction. Part of it goes through resistor 1, the other part goes through resistor 2. Coming out of resistor 1 and out of resistor 2 join up at this junction, at which point the current then flows into here. And then the current flows from here into the power supply. So to figure out the current flowing out of resistor 3, that's where we disconnect. Current flowing out of resistor 3 will indeed go through the meter and then into the power supply. So let's turn this thing on. That is the current flowing out of resistor 3. And that is the lab.